I'm Nova.
I'm Alloy, and this is AgentStack Daily.
OpenAI's terminal-based coding agent Codex shipped 0.1445 with broader dangerous command detection, catching more forced RM variants and explaining refusals more clearly. Anthropic's terminal-based AI coding agent Claude Code moved to 0.205. Moonshot Ari's Kimi K3 and Meta's Muse Spark 1.1 both arrived on OpenRouter with million-token context windows, while developers are building agents that search entire repositories without reading every file, reason across mixed media, and query code through persistent knowledge graphs.
Today, Codex and Claude Code releases 2 million token models, Code Search claiming 98% lower token use, and a 27 billion parameter model compressed into 2-bit weights. You'll hear about NVIDIA taking the top overall RTB retrieval spot, OpenAI's state-led safety proposal, research agents that remember failed searches, and an expanding MCP ecosystem led by FastMCP at more than 26,000 stars.
OpenAI shipped Codex 0.1445 on July 16. The terminal-based coding agent now recognizes more forms of forced RM commands as dangerous and provides clearer explanations when it blocks one. That matters because shell commands can erase files immediately, and coding agents sometimes construct a destructive command from a mistaken path, an ambiguous instruction, or a faulty assumption about the current directory. The release adds more tripwires around those cases without removing Codex's broader ability to operate a shell.
Clearer refusals improve more than safety. A generic denial leaves a person guessing whether the command, its flags, or the target path triggered the block. A specific explanation makes the interruption understandable and recoverable. Someone can reformulate the operation, choose a less destructive command, or explicitly authorize an action that was intentional. A near disaster becomes a visible decision point rather than a silent execution or an unexplained dead end.
Anthropic also published 0.205 for the terminal-based AI coding agent Claude Code as a stable release on July 8. Anthropic did not provide a changelog body describing individual fixes or features, so the concrete news is the stable build itself. Organizations that record exact agent versions for compliance, reproducibility, or controlled software environments now have a newer published build. Systems that track stable releases can recognize it automatically.
These releases show two different kinds of maintenance. Codex documents a narrow safeguard with an obvious human consequence, fewer destructive shell commands reaching execution and more useful explanations when they are refused. Claude Code provides a new stable artifact without detailed public notes. Neither changes the basic job of a coding agent, but both affect the foundation under unattended work. As agents gain authority over repositories, terminals, and deployment environments, a small patch that interrupts one dangerous command can matter more than a visible interface feature. Moonshot AI's Kimi K3 is now available through OpenRouter as an ultra-large-scale, open-weight multimodal reasoning model. Its listed context capacity is 1,048,576 tokens, roughly 1 million tokens in a single request. Moonshot positions it for complex coding, knowledge work, and long-horizon agentic workflows, meaning tasks in which software plans, calls tools, reads results, and continues across many steps.
That capacity can hold a large repository, extensive technical documentation, a long meeting archive, or a substantial collection of contracts without requiring every input to be split into tiny pieces first. A larger window does not guarantee accurate reasoning across all of that material, but it gives the model room to retain the plan, source material, tool responses, and intermediate decisions together. That can simplify systems that previously depended on aggressive chunking and repeated summaries.
K3's open-weight positioning also separates it from models that are available only behind a closed service. Open weights can support inspection, adaptation, and deployment options beyond the router, depending on the eventual distribution and hardware requirements. OpenRouter provides an immediate shared access point, allowing products to route requests to K3 through the same service used for other providers rather than adding a dedicated integration.
Useful applications include repository-wide dependency analysis, document-heavy investigations, and agents that need to preserve a long history of actions. The unanswered questions are cost, latency, multimodal performance, and retrieval accuracy when important facts sit deep inside the million-token window. A model can technically accept an enormous prompt while still overlooking details in the middle. Independent long-context results will show whether K3 converts capacity into dependable recall. Meta's Muse Spark 1.1 has also appeared on OpenRouter with a listed context window of 1,048,576 tokens. OpenRouter describes it as a multimodal reasoning model built for agentic tasks. It accepts text, images, video, audio, and PDF documents, then produces text. Those input types allow one request to combine material that many systems still process through separate pipelines.
A product could place a PDF report, photographs, an audio recording, and related correspondence into one working context. A media assistant could compare spoken claims with frames from a video and written source material. A maintenance system could combine a photographed fault, a recorded technician note, and a service manual. A legal or research agent could retain a large evidence packet while making tool calls and documenting conclusions.
The listing does not provide independent benchmark results, latency measurements, or detailed pricing evidence. Those omissions matter because a million-token limit describes capacity, not the quality of attention across the entire window. Video and audio also expand input volume quickly, so real requests may carry meaningful processing costs even when they remain below the stated limit. Multimodal support likewise varies in depth. Accepting a file does not prove precise temporal or visual reasoning.
Muse Spark 1.1 broadens the choices available through a common routing layer, especially for products that need more than text. Its strongest use cases will likely involve mixed evidence rather than simply filling the window with prose. Community results should reveal how accurately it retrieves details buried far apart, whether it follows long-running plans without drifting, and how quickly it processes large media collections. Those outcomes will determine whether the million-token specification reduces application complexity or merely moves that complexity into model behavior.
Minishlab's Semble targets one of the least glamorous costs in coding agents, locating relevant code. A common agent workflow searches for a keyword with grep, opens every matching file, and feeds large sections of source into the model. Semble instead returns focused code search results designed for agents. Its maintainers claim roughly 98% fewer tokens than a typical grep-then-read workflow.
The claimed saving comes from reducing irrelevant context. When an agent needs to find a function's callers, trace a configuration value, or identify the code behind an error message, whole file reads can overwhelm the useful lines with imports, comments, unrelated methods, and generated material. Focused retrieval preserves more of the model's context for reasoning about the change rather than spending it on navigation.
Semble.51 shipped on July 13. The repository had reached 5,634 GitHub stars and received more code on July 17, indicating active interest and continued development. The 98% figure comes from the project itself rather than a broad independent comparison, so it should be read as a maintainer claim tied to its chosen baseline. Even so, the underlying pressure is real. Retrieval often dominates both token consumption and elapsed time in repository-scale agent work.
Lower retrieval volume can make iterative tasks more viable. A refactoring agent may search dozens of times before editing anything, and every unnecessary file read compounds cost. Semble offers coding products a specialized search layer that can return relevant code with nearby context. Adoption by editors and agent harnesses would make the largest difference because people would receive the saving without rebuilding their workflows. The next evidence to watch is performance on multilingual monorepos, generated code, and repositories where names alone do not reveal relationships. The open-source database tool Hood shipped .121 on July 16. The project describes its position as where data access meets operational intelligence, placing database exploration and operational visibility in the same product. Its repository had about 4,930 GitHub stars and received fresh activity after the release.
Database work often spans several products. Developers inspect tables and issue queries in one interface, then move to separate monitoring software when latency, connection pressure, or workload behavior becomes important. WADP's pitch is to narrow that gap. A shared surface can keep the data being inspected close to the operational conditions around it, reducing the jump between a query client and an observability dashboard.
The project remains below a 1.0 release, but its 0.121 numbering reflects sustained public iteration rather than a new prototype. Nearly 5,000 stars provide a meaningful community marker in a category with mature commercial competitors. Continued commits immediately after a release suggest that contributors are actively addressing a backlog, although star counts alone do not establish production reliability or the depth of database support.
WADP can appeal to small teams that want an open-source database interface without assembling several paid tools before the workload demands them. It also creates a potential surface for AI-assisted operations. A product that understands schema, query history, and operational context could explain anomalous behavior or help people find relevant data without exposing unrestricted database control. The important next changes will be concrete connectors, permissions, operational views, and evidence that teams use it on live systems. Those details will decide whether the broad tagline becomes a durable alternative to separate access and monitoring products. Hugging Face's Transformers library shipped 5.14 on July 16 with 2 targeted fixes for Inkling integration. Transformers is a widely used toolkit for loading and running open-weight models, so narrow compatibility fixes can affect many downstream inference systems even when the release adds no visible feature.
The first repair covers assisted generation when an encoder-decoder cache is present. Assisted generation uses a smaller draft model to propose tokens, then asks the larger model to verify them. Accepting several proposed tokens can speed output compared with generating every token independently. An encoder-decoder cache stores the intermediate attention information used by models that process input and output through separate stages. Inkling could fail along that path. 5.14 repairs it.
The second fix applies during pre-fill, when a model processes the prompt before generating a response. It covers Inkling using a static cache, scaled dot-product attention, unpadded input, and position bias. In ordinary language, that combination reserves memory in advance, runs an efficient attention calculation, avoids adding filler tokens, and still tells the model where tokens belong. The interaction previously broke. The patch restores it.
These are compatibility repairs rather than a new programming interface. They matter to people self-hosting Inkling because 2 legitimate inference configurations no longer crash. They also illustrate how model integrations can fail at the intersections between caching, attention kernels, input shapes, and model-specific position handling. A checkpoint may load correctly yet still break only when acceleration features are combined. Transformers 5.14 closes 2 such intersections and gives inference services a more dependable path for assisted decoding and pre-allocate memory. PrismML's ternary bonsai 27B is attracting attention on Hugging Face. It is a 27 billion parameter open conversational model distilled into 2-bit ternary weights and distributed as a gguf file. gguf is a model package used by llama.cpp, a local inference runtime that can run models across CPUs and supported GPUs. The repository had passed 200,000 downloads and recorded 637 likes.
Ternary weights represent model values with a very small set of possibilities, allowing unusually compact storage. Combined with roughly 2 bits per weight, that reduces the resident memory needed for a 27 billion parameter model. The package lists llama.cpp, CUDA for NVIDIA hardware, and Metal for Apple hardware. That broadens the machines capable of attempting local inference, including well-equipped laptops and consumer GPUs that could not comfortably hold a higher precision 27 billion parameter checkpoint.
The model also uses a hybrid attention block design, pairing aggressive compression with changes intended to preserve useful conversational behavior. Local agents could use it for private document interactions, offline assistance, or repeated background tasks without sending every prompt to a cloud provider. Compact weights also reduce download and storage pressure, though runtime memory still includes the context cache and other working data.
Compression creates an unavoidable quality question. 2-bit models can lose reasoning accuracy, instruction adherence, or fluency compared with larger representations, and the available material does not establish how Turner-Bonsai compares with its upstream model on independent evaluations. Its download count proves substantial curiosity and practical exercise, not parity with fuller precision alternatives. Hardware throughput, usable context length, and quality under long conversations will determine whether it becomes a dependable local agent model or remains an impressive demonstration of memory efficiency. NVIDIA's Nematron 3 embed took the top overall position on RTEB, a retrieval embedding leaderboard highlighted by Hugging Face. An embedding model converts text into numeric representations that place related passages near one another. Search systems use those representations to retrieve relevant material from large collections before another model writes an answer or takes an action.
Retrieval quality directly affects agent reliability. If an assistant receives the wrong policy page, an outdated code example, or a superficially similar customer record, stronger reasoning cannot fully repair the missing evidence. A higher-ranking embedding model can improve which passages reach the model in the first place. RTEB aggregates multiple retrieval tasks, so the overall result carries more weight than a win on one narrow dataset.
NVIDIA's result gives teams a new candidate for semantic search, retrieval-augmented generation, document discovery, and agent memory. A support assistant could retrieve the right troubleshooting article, a coding system could locate conceptually related functions even when names differ, a research product could match a question with passages that do not repeat its exact words. The leaderboard position is a reported benchmark result, not proof that every private dataset will improve equally.
Nematron 3 embeds value will depend on deployment cost, language coverage, maximum input size, and behavior on specialized domains. NVIDIA customers may also benefit from an inference stack designed around the company's hardware and software. Independent reproductions and domain-specific deployments will show whether the top overall RTEB position translates into fewer retrieval errors in production. Even a modest improvement can compound across an agent that searches repeatedly, because each better result shapes every decision that follows. OpenAI published a policy proposal on July 15 calling for reverse federalism in AI safety. Under that approach, states would develop early rules and produce evidence about what works, then those lessons would inform a national framework. The proposal reverses the familiar arrangement in which federal law establishes a baseline and states add stricter requirements.
State legislatures are already considering different obligations for developers and deployers, including transparency, safety, discrimination, and accountability measures. OpenAI argues that this variation can function as experimentation rather than merely fragmentation. States can expose trade-offs through actual implementation, and federal lawmakers can later use those results when constructing broader rules.
The document expresses a company position. It does not create law or change anyone's compliance duties. OpenAI also has a commercial interest in the eventual shape of regulation, so its proposal belongs inside a larger contest over whether national rules should preserve, coordinate, or replace state authority. A patchwork can generate useful evidence, but it can also force products to meet different requirements across borders and give people unequal protections.
The next consequential question is federal preemption, whether Congress would adopt one national framework that displaces some state laws. If preemption arrives quickly, states may have little time to generate the evidence OpenAI says it wants. If it does not, companies may operate under diverging state rules for years. Product teams do not receive a new obligation from this proposal, but the debate could shape documentation, safety reporting, and liability requirements long before a comprehensive federal statute appears. SearchOS addresses research agents that repeat similar searches, forget failed approaches, or stop before covering every part of a question. It represents open-ended research as linked tables of entities and attributes, with each value connected to evidence. That makes missing information visible rather than leaving completion to the model's intuition.
The framework stores 4 kinds of shared state outside the model: pending work, an evidence graph connecting claims to sources, a coverage map showing unanswered gaps, and a memory of strategies that failed. Subagents work in parallel, and a completed worker is replaced with a task aimed at an uncovered gap. External state gives the system durable memory across searches and prevents multiple workers from repeating the same dead end. The research points toward agents that stop based on documented coverage rather than fatigue or context pressure.
A 2022 engineering analysis called Mysteries of Telegram Data Centers returned to prominence with 262 points on Hacker News and a parallel discussion on lobsters. 4-year-old infrastructure writing rarely resurfaces at that level unless readers still find its reasoning relevant. The piece examines Telegram's physical and network footprint, an area about which the company has historically disclosed limited detail.
Telegram operates a globally distributed messaging service with demanding latency, availability, and jurisdictional constraints. Understanding where such a service places capacity can reveal how a large communication platform balances distance, network connectivity, resilience, and legal exposure. Because public information is incomplete, the analysis reconstructs likely choices from observable evidence rather than presenting an official architecture.
The renewed discussion adds value by placing the original claims next to newer industry knowledge. Readers can identify which assumptions have aged well, which infrastructure conditions changed, and where uncertainty remains. The attraction extends beyond Telegram. Any product serving real-time conversations across regions faces related decisions about replication, routing, failover, and how much operational detail to disclose.
The resurgence also shows why older technical investigations retain value. Physical infrastructure changes more slowly than application interfaces, and a careful analysis can remain useful even when individual providers evolve. The 262-point response measures attention rather than correctness, but it indicates sustained interest in the hidden systems beneath global messaging. For AI products adding persistent chat, streaming responses, and geographically distributed users, those underlying constraints still determine latency and reliability. Models may change rapidly, networks, data centers, and regional boundaries continue to set hard limits. Mmishalok measures whether coding agents can use screenshots to locate bugs. The benchmark contains 652 real-issue and fixed pairs across 23 programming languages. Screenshots include evidence common in actual reports, broken interfaces, browser errors, malformed output, and visible rendering problems.
The best-tested agent placed the correct file among its top 5 guesses only 39% of the time when screenshots accompanied the written issue. Strong performance on text-only coding tasks did not transfer cleanly to visual issue localization. The result exposes a gap between describing an image and connecting its evidence to the responsible source file. Coding products that accept screenshots still need deeper links between visual understanding, interface structure, runtime behavior, and repository search before they can reliably turn a pictured defect into the right edit. Deastata's Codebase Memory MCP indexes a repository into a persistent knowledge graph and exposes queries through MCP, the model context protocol used by AI applications to discover tools and retrieve structured information. Point 9 shipped July 8, and the repository had reached 32,285 GitHub stars. It is distributed as a single static binary with no external dependencies.
A knowledge graph records relationships among code elements rather than treating source as undifferentiated text. An agent can ask which functions call a method, where a configuration value is used, or which modules depend on a component. The repository claims indexing takes milliseconds for an average codebase, queries return in under a millisecond, and language support covers 158 languages.
The maintainers also claim 99% fewer tokens than sending raw source to a model. Instead of repeatedly opening entire files, an agent receives a compact answer drawn from an existing structural index. That can reduce context consumption and accelerate repeated questions during debugging, refactoring, or repository onboarding. As with Semble's 98% claim, the comparison comes from the project and depends on its baseline and codebase characteristics.
MCP makes the index available to compatible coding applications without requiring each one to invent a custom protocol. A terminal agent, editor assistant, or private automation service can call the same query surface. Persistent indexing also gives the agent memory between requests rather than forcing it to rediscover the repository on every turn. Large monorepos, generated code, and rapid branch changes will provide the hardest evidence. The project's traction suggests strong demand for structural code retrieval that is faster and more economical than repeatedly placing source files into a model's context. Prefect HQ's FastMCP has crossed 26,000 GitHub stars. The open-source library presents a Pythonic way to build MCP servers and clients, allowing developers to expose ordinary Python functions as tools that compatible AI applications can discover and call. Version 3.4 shipped July 9, followed by more repository activity on July 16.
MCP standardizes the exchange between an AI client and an external capability. A server describes available tools, their inputs, and their outputs. A client discovers those descriptions and invokes a selected tool. Without a framework, developers must manage protocol messages, transport behavior, validation, and lifecycle details. FastMCP wraps much of that work in familiar Python patterns.
A small company could expose an internal search service, inventory lookup, ticketing action, or analytics query through one server. The same capability can then appear in multiple MCP-compatible clients instead of being rebuilt separately for every assistant. FastMCP also supports clients, giving Python applications a shared library for both offering and consuming tools. More than 26,000 stars indicate that many developers view it as an accessible entry point, although stars do not reveal how many installations run in production.
The combination of high visibility and frequent releases gives FastMCP influence over how Python developers understand the protocol. Convenience can accelerate useful integrations, but it also increases the importance of stable interfaces, secure defaults, permission boundaries, and clear upgrade behavior. As MCP applications move from demonstrations into business systems, FastMCP's handling of authentication, remote transports, errors, and long-running operations will matter as much as its concise syntax. Its growth shows that MCP development is becoming a software category, not merely a feature inside individual AI clients. Microsoft's MCP for Beginners enters the radar with 16,772 stars and an update on July 16. The open-source curriculum explains MCP through working examples in .NET, Java, TypeScript, JavaScript, Rust, and Python. Its traction comes from both Microsoft's backing and the need for examples beyond a single language. Teams can reuse the samples to expose existing back-end functions as agent tools while keeping the same protocol concepts across services written in different stacks.
CoPlayDev's Unity MCP has 12,580 stars, and 10.1 shipped July 13. It connects AI assistants to the Unity editor, exposing tools for assets, scenes, scripts, and editor automation. The bridge lets an agent inspect and alter the running development environment instead of editing C# files without seeing scene state. That opens uses such as placing objects, changing lighting, swapping assets, and coordinating code changes with editor actions. Its integration value comes from giving coding agents structured access to Unity-specific operations.
MCP use has 10,323 stars. Version 1.34 shipped July 8, and the repository was updated again on July 17. It is a full-stack framework for MCP servers, AI agents, and MCP apps that run inside ChatGPT and Claude clients. Shared primitives can support several client surfaces from one implementation, reducing the adapter code needed for every destination. Its traction reflects demand for orchestration above individual tool servers. One entry point can compose multiple MCP capabilities and present them through browser and chat experiences.
Moonshot AI's Kimi K3 is newly available through OpenRouter with 1,048,576 tokens of context. It is an open-weight multimodal reasoning model aimed at complex coding, knowledge work, and long-running agents. The combination makes it notable for repository-scale analysis and research jobs that need to preserve tools, evidence, and intermediate decisions in one context. Its listing does not state active or total parameter counts, so the public evidence supports the context and workload claims without supporting a size comparison.
Meta, Muse Spark 1.1 also arrives through OpenRouter with 1,048,576 tokens. It accepts text, images, video, audio, and PDFs and returns text, with an emphasis on agentic tasks. Mixed media input distinguishes it for workflows that need to compare documents, recordings, and visual evidence without routing each format through a separate model. Parameter counts are not listed, and independent latency or benchmark results remain the evidence needed to judge how much of that enormous window stays useful in practice.
The ternary Bonsai 27B GUF package from PrismML carries a 27 billion parameter conversational model in GGUF with 2-bit ternary weights. A hybrid attention design and compact weight representation reduce resident memory enough to make the model plausible on consumer GPUs and well-equipped laptops. Llama.cpp supplies local inference, CUDA supports NVIDIA hardware, and Metal supports Apple systems. More than 200,000 Hugging Face downloads show substantial use and curiosity. It offers private, offline conversational inference at a size that usually demands much more memory, while leaving quality, context capacity, and sustained throughput as the decisive measures. The download count demonstrates real experimentation, but it does not establish parity with fuller precision models. Long conversation quality and measured throughput still decide whether the memory savings are worthwhile.
Firecrawl MCP server has 6,978 GitHub stars. It exposes web search, scraping, and crawling as agent tools and converts retrieved pages into structured markdown before returning them. That can give models cleaner, more token-efficient material than raw page markup. Support for standard local and streaming transports allows compatible clients to add live web collection without implementing Firecrawl's service interface independently. A listed September release and fresh repository activity show the integration remains actively maintained.
Sentry's Xcode Build MCP has 6,081 stars. It wraps Xcode build commands and simulator controls as structured MCP tools for iOS and macOS development. An agent can request builds, boot simulators, or invoke testing functions through defined calls rather than parsing an improvised terminal session. That connects coding decisions with the Apple toolchain and gives assistants direct evidence from compilation and simulator state.
The Nanbinx's 5ire project has 5,277 stars. It is a cross-platform desktop AI assistant and MCP client that supports major model providers, local knowledge bases, and external tools. It discovers registered MCP tools and translates their calls into the desktop application's native function interface. 5ire matters as a user-facing destination for the expanding server ecosystem. People can combine different providers, private material, and interoperable tools inside one desktop surface.
Codex adds clearer protection around destructive shell commands. Kimi K3 and Muse Spark 1.1 expand long context and multimodal choices. Semble and Codebase Memory MCP attack the cost of repository retrieval. Hood brings database access closer to operational context. Transformers repairs 2 Inkling inference paths. And ternary Bonsai makes a compressed 27 billion parameter model more accessible on local hardware. The strongest near-term signals are measurable: repository scale token savings, concrete star and download traction, and compatibility fixes that remove known crash paths.
Nematron 3 Embed raises the retrieval benchmark bar, SearchOS gives research agents durable shared memory, and MMIssueLOC shows that screenshot-driven debugging remains unsolved. FastMCP, Microsoft's curriculum, Unity MCP, and MCP use show MCP spreading from protocol basics into development environments and full applications.
For release details, project sources, and further reading, look at the show notes at tobeyonfitnesstech.com. Thanks for listening to AgentStack Daily. We'll be back soon.